During World War II, soldiers and civilians faced dangers that went far beyond bullets and bombs. In underground bunkers, tank interiors, and makeshift hospitals, there was another invisible killer: dust, smoke, and toxic air. Ventilation was a matter of survival, yet electricity was often unavailable or too precious to waste. Out of that necessity came one of the most remarkable forgotten inventions of the war: an air filtration system that worked without a single watt of power. It could purify the air in a sealed shelter using nothing but mechanical design and simple materials, allowing soldiers to breathe safely even in chemical or smoke-filled environments. This forgotten wartime innovation didn't just protect troops. It laid the groundwork for passive air systems still used in survival shelters, submarines, and even space capsules decades later. Today, the story of this lost air filter is a perfect reminder that ingenuity thrives most when resources are scarce. In 1939, as Europe descended into total war, air quality became a battlefield issue. Cities were bombed nightly, creating clouds of smoke and fine debris. Civilians fled into basements and bomb shelters, sealing themselves away from falling shrapnel, but also from fresh air. At the same time, chemical warfare was a looming threat. Armies needed ways to protect personnel inside tanks, bunkers, and field hospitals from both dust and toxic gas without relying on electrical systems that could fail or give away their position. The problem was clear filtration had to be passive, durable, and easy to maintain. Engineers in Britain, Germany, and the United States all raced to create self-sustaining air systems. While powered filters existed, using fans or pumps, these were often too large, noisy, or dependent on unstable electricity supplies. The solution came from an unexpected source: a combination of natural air movement and clever materials science. The breakthrough came with a device known as the passive displacement air filter, which was designed to purify air using pressure differentials and chemical absorption. It really relied on one simple physical principle: when air passes through fine layers of porous material, particles and contaminants get trapped, while clean air continues to flow. Instead of an electric fan, the filter used what engineers called a chimney draft or thermal siphon. When warm air naturally rises, it creates a slight suction effect that draws cooler air through an inlet. By designing the shelter with a higher outlet vent and a lower inlet connected to the filter, they created a self-sustaining airflow cycle. It was quiet, constant, and, required no power source at all. The filtering unit itself was a masterpiece of wartime simplicity. It consisted of multiple layers: coarse fabric for dust, fine cloth for smoke, and an activated charcoal bed to absorb chemical vapours. Some military versions even added a lime soda mix to neutralize acidic gases like chlorine or sulfur. Air entering the filter passed through each layer in sequence, emerging clean enough to breathe, even in areas heavy with dust, smoke, or, mild chemical agents. The British Civil Defence and the United States Army Corps of Engineers both adopted variations of this design for field bunkers and tank crews. By the war's midpoint, thousands of these manual systems were in use across Europe and the Pacific, keeping confined spaces breathable for hours or even days. In the field, the non-electric air filter was honestly a lifesaver. Infantry engineers often built them into underground command posts, connecting the intake pipe outside the bunker with flexible tubing packed with filtration material. The simplest models were made from locally available items: layers of oiled cloth, charcoal made from burnt wood, and lime dust packed into metal canisters. Civilians in bomb shelters also adopted the same principles. The British Home Office distributed pamphlets teaching citizens how to build hand-pumped air purifiers based on the same airflow system. Even without pumps, the natural chimney effect provided steady circulation, as long as there was a small difference in temperature between inside and outside air. In tropical theatres, US troops improved the design by placing the inlet pipe near shaded ground and the outlet near a sun-warmed area, enhancing the airflow naturally. For modern survivalists, the same method remains incredibly relevant. A simple, electricity-free air filter can be made using basic materials. Start with a large metal or PVC pipe for the intake, then fill a section of it with alternating layers of cloth, charcoal, and fine sand or filter paper. Seal the ends with mesh to hold the layers in place. As air naturally moves through the pipe, from cooler to warmer zones, it will passively filter itself. This can provide continuous ventilation for a small shelter or workshop without the need for any electrical device. After the Second World War, the technology behind the passive air filter, kind of evolved into several important civilian and military systems. The same principles were actually applied to submarine scrubbers, fallout shelters, and even early spacecraft environmental controls. NASA's early capsule life support systems, for instance, used a version of the wartime charcoal absorption process to remove carbon dioxide and contaminants from cabin air. In the civilian world, non-electric air filters started to appear in post-war emergency kits and Cold War fallout shelters. The simplicity of the design, no moving parts, no electricity, made it, pretty much ideal for long-term preparedness. It also inspired modern off-grid ventilation systems that use passive airflow combined with HEPA and activated carbon filters for, sustainable indoor air quality. Even today, environmental engineers and survival experts still reference that World War II concept when they're designing air systems for disaster zones. Its enduring legacy isn't just about what it accomplished back then, but really in how it redefined efficiency, showing us that sometimes the best power source is, none at all. The lost World War II air filter is more than just a historical curiosity. It's really a lesson in engineering restraint. During wartime, scientists and soldiers didn't have the luxury of high-tech components or, endless energy. They had to use what nature provided: heat, pressure, and chemistry, to create solutions that actually worked under the harshest conditions. The result was a self-sustaining air purifier that could run indefinitely, as long as the air kept moving. For survivalists, historians, or honestly anyone studying resilience, this system offers a blueprint for independence. It shows how understanding physical principles can truly replace our reliance on technology. Whether you're building an off-grid cabin, preparing a safe room, or restoring a wartime relic, The idea of filtration without power remains both practical and, well, pretty profound. The World War II air filter that worked without electricity stands as a symbol of ingenuity under pressure. In an age where we depend on machines for even the simplest comforts, it reminds us that the laws of nature, heat rising, air moving, charcoal absorbing, can still keep us alive. This forgotten invention didn't just clean air, it gave people a reason to breathe easier when the world above was burning. If you found this story as fascinating as we did, subscribe to In the Beginning, share it with fellow history enthusiasts, and help keep these stories of human creativity and survival alive. Because in every forgotten invention, there's a piece of wisdom waiting to be rediscovered. And sometimes it's the simplest designs that endure the longest.